Now there's more specific ways to describe concentration, and let's start building our understanding of that here. So take a look at the images here, and what do you notice about the dilute beakers? All right, so everybody in this line is considered dilute, and versus the concentrated beakers, everybody in this line is considered concentrated. Okay, hopefully you noticed that the dilute concentrations have these smaller numbers in front of this M, whatever this M is, and the concentrated have these larger numbers. Okay, now take another look at these beakers and tell me, does the volume of the solvent matter? All right, hopefully you said no, and you take a look at this beaker number 5. He has, or she has, a concentration here of this 3M. We haven't really talked about the M yet, which is the same as the rest of the concentrated ones, but notice that the volume is different than the other ones. So no, the volume of the solvent does not necessarily matter. So if we're looking at dilute versus concentrated, and we want to be more specific, we're going to start using this new term here, M, which stands for molarity. And molarity is known as, or is a unit for concentration. And molarity, okay, this is a ratio of the moles of our solute, I'll move this over just a little bit, of our solute over the liters of our solution. Okay, the symbol for molarity, as you can see here in the picture, the symbol for molarity is this capital M. All right, so this here, this guy right here, we would say is a 3 molar solution of copper chloride, copper 2 chloride solution. All right, and to get our molarity, if you take a look, notice in number 1, beaker 1 right here, you can see that we have 0.06 moles of our copper 2 chloride, right? And we see that it is in 0.06 liters of solution. So if we divide 0.06 by 0.06, that means we will get 1, and hence it is a 1 molar. And I write the line underneath there, guys, like I just did. I do it without even thinking. This right here, that's because in college my professor, Dr. Brewer, always did it. So that's just my quirk. All right, it's just a capital M. So 1 molar copper 2 chloride. So pause the video, take a minute, and convince yourself that of the rest. Make sure that this number of moles and this volume will actually make a 3 molar solution. Right? Make sure that this makes a 3 molar solution. Convince yourself that the calculations work. Okay, so next, let's try a couple of problems, maybe? Yes, hold on. Yep, so let's try a couple of problems in the Ed puzzle. Okay, so hopefully in the Ed puzzle, when you had that 1.5, let's try it with a pen, that 1.5 moles of sodium chloride, and it was in 0.5 liters, so hopefully you divided that, and that gave you the 3.0 molar solution of NaCl. And for that second one, hopefully you took 0.40 moles of acetic acid, which is really vinegar. Vinegar is weak or dilute acetic acid. So if we had acetic acid and you divided that by the volume of solution, which was 0.250 liters of solution, and that's how you got 1.6 molar acetic acid. Okay, so your next question on the Ed puzzle is going to be to try to solve this one. So take a minute, read the question, and then let's try to solve it on Ed puzzle. Now, if you aren't doing this with Ed puzzle, pause the video and try the problem. Okay, so A, hopefully, when you were doing it, you found or said that no, you cannot calculate the molarity using the numbers in here, using this 74.55 grams and 2,000 milliliters, because if you did that, that actually will give you a value of 0.04. That's that 75 or 74.55 divided by 2,000. But notice it gives you units. If I keep my units that they gave me, it's grams per milliliter. Now that's not the units that we use for molarity, right? So no, you cannot get the molarity using grams and milliliters. And hopefully you noticed on this bottom part that the required units for this, for molarity, are moles of our solute, right? And we need liters of our solution, right? So our 74.5 grams of potassium chloride, we would first need to change that into moles. And remember, you need to use the molar mass for that, okay? So let's do another example. If I have 2.5 grams, I'm draw a line, right? This is a new example, guys. 2.5 grams of copper 2 chloride, and that's in 1 liter, 1.0. All right, so if you're in my class, you know that I'm a stickler about the significant figures. It's another one of my quirks. 1.0 liters of solution. What's the molarity? Well, notice this example that was given in grams. So the first thing we have to do is we need to get that into moles. So we take our 2.5 grams of our copper 2 chloride, and we need to convert that into moles. And we know that 1 mole of copper 2 chloride weighs or has a mass of 134 grams of copper 2 chloride. So that is in fact a 0.019 moles of copper 2 chloride. And so to find the molarity, we don't use 2.5 grams, we use 0.019 moles of our copper 2 chloride, and we need to divide that by the liters of solution. And in this problem, the solution was already given in liters, so we didn't need to change the units. So we know it's 1.0 liters of solution, which means that we will get a solution or a concentration of 0.019 molar copper 2 chloride. Now go ahead and try those 3 practice problems in the Ed puzzle.